Thank you for coming. My name is Fernanda Foertter. I work at Oak Ridge National Lab. My role there is HPC User Assistance Specialist. It is a glorified title. Basically, I'm tech support for scientists who try to run on a supercomputer. But my biggest role is actually training lead. So I run a lot of the workshops and things that we do at the lab to try to help people to run on the supercomputers. How do I clicky clicky? Nope. Oh. Thank you. All right. So what is a leadership computing facility? Well, we have the largest supercomputers in the world, and we're really proud of it. There is actually 2 leadership supercomputing facilities in the United States. One is at Argonne National Lab over in Chicago. It's called the Argonne Leadership Computing Facility. And then the one where I work, it's called the Oak Ridge Leadership Computing Facility over at Oak Ridge, Tennessee. And I live there, and it's a lovely town, and the frogs glow a little bit of green, but that's okay. We like it. So the goal of these supercomputers is to do the kind of science that's impossible. There's no other place that you can do the science. And by the time they get to us, they haven't had access to a computer this large. So, how do we even get to help folks to use these computers? And so that's the problem that I try to solve every day. It's highly competitive. We've been able to receive just about as every year about 100 projects come to our lab and get accepted. But for the most part, we're quite a bit oversubscribed in the number of projects that try to apply to get time. We partner with users a lot to get their applications ready. And in fact, every time we have a new computer to onboard, we partner with them. But our mission is basically to do impossible science. And we do that very well. If I can get to the next thing. There you go. So we've delivered 5 systems in 10 years. And that's pretty amazing. It's all actually come from a single vendor. We've had a partnership very long with Cray. And we started in about 2004. The first computer, Phoenix, was the sort of a vector machine, and then we went on to a dual-core upgrade, and then we went on to a quad-core upgrade, and then a 6-core upgrade, and you can see what's happening to the cores. Right around 2004 is when multi-core started coming online. And so we've had to help users not just come from regular clusters or institutional clusters or even their desktop, but we've had to help them get their applications ready to then migrate to these new architectures that were coming online. And Titan was probably one of the biggest paradigm shifts for users coming to our center. Titan has GPUs in each node. So it has a regular multi-core, just like most people are used to on their desktop. But, I mean, even today, I don't have my phone with me, but even today our phones have multi-cores in them. And so parallelism is increasing, and we've had to partner with these designers and architects for a very long time. So we've had this role with vendors from way back when we started to compute, and we used to be able to kind of walk around and say, we're government, here's some money, build us something, and we're here to help. We're government, we're here to help. But we can't do that anymore. And so what we've had to do now is pool our money together, because it turns out games are actually the big game in town. And so that's what made GPUs cheap for us, but we're not, we wave around a few $100 million, and vendors kind of go, that's nice. So we had to pull our money together, and we had to come together and say, now we're going to do a bigger procurement. And that procurement was called Coral, and 3 labs got together within the DOE ecosystem. That's the Department of Energy here in the United States. And we did a procurement of 3 machines. And there was just one rule that the DOE wanted to follow. And that rule was that we had to have at least 2 architectures that were distinct from each other. So we could not all get the same machine. And the vendors knew that. And we ended up procuring 2 machines that are power-based. So we have Lawrence Livermore and Oak Ridge are getting a power-based, GPU-based machine. And then the other lab, which is Argonne, is getting sort of a Blue Gene-like, which is interesting how we've shifted today, CPU-based machine, which is based on Knight's Landy. And thank you. So we're not alone, and I don't mean aliens. I mean in terms of how we collaborate with people, we're not alone. We get to collaborate with centers every day, so now we're collaborating on procurements. We've long collaborated with vendor partners on how to build these machines for users and how to meet their scientific needs. Again, our goal is very, very humble. We're trying to do impossible science on supercomputers, so we really have to partner very strongly with vendors to build things that scientists can not only use, but program well. But there are currently two paths, and that's something that we have to, manage. We can't just ignore. We can't just say, here's our machine, and we're just going to teach people how to do our machine and hope that people come. We really have to manage the ecosystem that lives within the DOE system. And so now there's a mini-core and there's a hybrid multi-core, and that's what we're seeing move forward in the next at least 5 to maybe 8 years. That's what we're going to see move forward. So the path of future architecture shows increasing parallelism. I think it's obvious by anyone. In fact, I think not too long ago, Intel just declared Moore's Law is done, at least for them on their end. I think a lot of us saw that coming. But the reality is Moore's Law really only got users about 2.5x speed up every 18 months. And a lot of that work still needs to be done on the software end. So for a long time, scientific and domain developers and domain scientists depended on Moore's Law to improve and increase the speed of their software, their scientific applications. And today they can't do that anymore. They're really going to have to think a little harder about how to do that. With Titan, that's given us a little bit of a head start because we really had to think about how to increase parallelism. We have 18,688 nodes, and each of those nodes have a GPU with some 2,600 cores in them, so they really had to think about increasing parallelism. So post-Moore Law area, we still have two architecture paths as far as the near future. One is very multi-core, the other one is very core. And I got cut off for a little bit. Trying to do my shirt. Okay. We're still grappling with these applications that last much longer than these computer systems do. So what do we do with these applications? Well, we have to partner. So we're talking about vendor partnership. We're talking about partnering with centers. Because at the center of this little circle here is the poor application domain developer. They have to deal with hardware that changes underneath them, whether they get an allocation. For example, we have a couple of allocation programs. They may get time on Oak Ridge, and they get time on Argonne. And what do you do with that application? It doesn't just automatically run on these systems. So things change underneath them really quickly. The tools change underneath them. Standards sometimes take too long to change in response to the hardware that comes along. And then their science goals are changing. And I don't envy computational scientists. I was a computational scientist for a while, and now I just get to help them, and I don't envy them at all, but I try to help them as much as I can because I do understand some of the burdens that they have to deal with. But this wheel of burden is, the conclusion here is basically to say, where you do your science actually may require some re-engineering. I don't know a lot of scientific fields where you have to, because you change location, you have to actually change the instruments and re-engineer your instrument to be able to take that piece of data. So right now, even within our own center, we have many ecosystems. We're going to run Titan, which is generic x86, all the way, plus the GPU, all the way to 2019. And then concurrently, we're going to onboard these power systems within the center. And right now, we have a generic cluster that's called Rhea that we use for post-processing and some other viz. We have another Cray system that's just based on Xeons at the center. We have even a viz lab. So we have all these ecosystems in the same laboratory that we're constantly trying to manage in a common set of tools and just to make it easy for the user to log in and not feel completely different from one place that they're logging into the next. So here are the partnerships that we rely on every day. My job is to partner with vendors. My job is to partner with centers. And so we've already partnered with centers for a very long time. We're kind of forced to play nice with each other, but we do enjoy each other. It's not a total negative. We do enjoy partnering with each other, but it is very, centers are very big, and it's just very, separate geographically, so we have to do the best we can on trying to meet in certain locations, and OpenPOWER is one of those locations, right? So OpenPOWER working groups and OpenPOWER Foundation allows us to all collaborate in a sort of a generic set of tools and generic APIs. We partner with vendors a lot on whether that's through non-recurring engineering or whether it's just telling them this is what our users need. I know that for compiler engineers and compiler vendors, they're always listening to me. Or I don't know if they listen, but I'm always telling them what compilers, what users need from compilers. And I try very hard to sort of advocate for the user. We always partner with organizations. I serve on lots of language standards, and I also serve on OpenPOWER and the academic working group and the accelerator working group. So all of that work goes into advocating for the user, for a common set of tools, common set of APIs, and all these things. And of course, we partner with our users. I mean, they're ultimately our customers. And I'm trying to help them do impossible science, and that's a really big job. So one way that I do that is through training. As I said, I'm training lead at Oak Ridge National Lab, or at least Oak Ridge Leadership Computing Facility within Oak Ridge National Lab. And this is where cross-pollination has really worked really well. I started running these things called hackathons. You probably heard them, Facebook and Google. But I decided to apply them to a scientific domain in a very specific, structured kind of way. And if you want to know more about it, you can talk to me after this talk. But the first one we ran was 2014, and then we ran 3 in 2015, and this year we're running 4. And what this allows is this cross-pollination between users, vendors, centers, and tool makers. They're all there at the hackathon, all talking to each other, and I don't have to be the middle person anymore advocating for these things to one another. And so what it's done for us, we've seen, even in the last maybe 15, 16 months, we've seen a rapid change in how tools have really become much more useful to the user simply because the developer was sitting right next to the user watching them do it. And that's a much different scenario from before, where we would get requirements, we would maybe ask in surveys, or maybe we'd sort of translate how users, we might imagine how users want to use the tools and what they need to do. So we get all these people together in one place, and we've really seen a huge amount of progress. Anyway, so partnering with us, and you might be asking, how do you partner? Well, we became associate members of OpenPOWER Foundation in 2015, and already we've joined some technical groups, both in I/O, Accelerator, and also the academic group. We are in open standards. We're serving in OpenMP, OpenACC, Fortran, C++, C, all of the MPI, all of the open standards. We try to make sure that we attend meetings and advocate for the future. And we're always trying to advocate for open standards. Open centers, we are across centers. So even if you're not partnering, for example, with a center that is going to get an IBM machine, I still encourage you to partner with centers that don't have those machines, because they also have needs that you might be able to meet in the future. And of course, we do open science. So if you're in the business of doing science, you do not have to be a US citizen. There are just a handful of countries that are unfortunately not allowed to run in our system because, things happen. But we do open science, and so long as it's not, I think, ITAR or defense, or you're not simulating something scary, you should be able to run in our center. It is paid for by the American taxpayer, so thank you, thank me. And you can run in our center even if you're a tool developer. So you don't have to be doing or having a scientific goal. You can be a tool developer and get some time in our systems to be able to understand and maybe port your application or your tool to our center. So this is very kumbaya. I warned a lot of people this is going to be a little kumbaya, but basically I really encourage everybody to collaborate with one another to try to exit these silos of I am a vendor, therefore here's a product that I'm packaging to you, and then asking them for their feedback, to really try to get that feedback as you're doing the development of your product and your application, or even your hardware. Scientific outcomes really do depend on these parties working together, because it does take a lot of time to port applications. And if a user has to do this every time a new machine comes around, we're holding back science. And I really want to advocate to not hold back science. So try to stay within the standards that already exist. Try to build upon those standards. And then if you can build upon those standards, try to advocate for other points of view too, and try to collaborate together. We would like to definitely partner with your organization. So if you are unsure how to begin, come talk to me. I'll be somewhere in the back there, and I can have that conversation with you on how your organization can partner with us. And again, you don't have to have a science problem necessarily. So if you're a tool builder or a vendor or even a hardware vendor and you'd like to partner with us about what it is that you're doing, we can definitely try to find a way to include you in our center and try to get that feedback to you on your endeavor. That's really all I have.